what is a primary index? Primary index is nothing but a key column which is used to identify a table. So basically, unique. There will be like two type of primary indexes: unique primary index and non-unique primary index. So Teradata is basically the data distribution is completely depends on the index, especially primary index. So I will connect to the database and I will just show you. So whenever you create a primary index, the data will be distributed based on the primary index through the AMS. So for example, whenever you create a table, right, so you define the primary index on that. So the data will be distributed evenly based on the primary index. And a table must have a primary index. So for example, I will just show you a table. Here for example, students is there a table. Before that, I will default database td underscore dev. That means we are defaulting the td database as td underscore dev while writing the queries, and select star from this table name, right? And if you say show select star from table name, so it will just give you the structure of the table here. If you see, this is the table definition. Create set table, students table, and name subject 1, subject 2, subject 3. These are the four columns, and primary index is created on the name field. And index, this is, I will tell you about index and unique index. So now we'll talk about primary index. So primary index is based on the name field here, right? So that is what a primary index means. And unique primary index will have the advantage of guaranteeing the distribution of the data evenly across all AMPs. Okay, and whenever we choose a where condition in a query or a join condition, make sure that we'll have the join conditions on the primary index, so that the performance of the query will be faster. Okay, so and primary index, how the data will be stored basically. So for example, the parsing engine will have the PI value based on the hashing algorithm. The primary index value will be chosen. I mean, the corresponding access from the AMP will be taken by the hashing algorithm. Okay, so based on your primary index, the hashing algorithm will give you a value, PI value, for the row to be stored in an AMP basically. Okay. So based on the PI value, it will determine the position of the row. And accessing the primary index value is always a single AMP operation. That is a very common and most important concept, and it's interview concepts as well. So primary index, when you choose and you are trying to get the data based on the primary index, it will be always a single AMP operation. Okay, and that is the best way to access a row in Teradata primary index. I will just show an example so that you'll understand it better. So here, if I run select star from students, right, I'll just show you the data in this select star from students. So I got 6 records, and this is the data. Now if I press F6 or if you press F5, then I will get the data. F6 will give you the explain plan of the query. Explain plan is nothing but how your query is actually reading based on your parsing engine. Okay, so first of all, we'll log this table to read the data, and then we do an all AMP retrieval from the students. So here we do an all AMP retrieval with all rows scan with no residual conditions. So this is very important because whenever we write select star from table, it will just take the entire table scan and all the amps will be involved in that. Okay. So this is what explain plan means. Explain plan is nothing but the way of accessing the data. Explain plan is nothing but the way of accessing the data by the parsing engine. Parsing engine will guide like such a way that it will access the data according to the distribution of the data. So here if you see, we do an all amp retrieval step from TD dev students from all row scan by the way of all row scan and all amp operation. This third row is important here, right? Now I'll just use primary index in the where clause now. We'll see how the data distribution will change, right? Select star from students where name is equals to Joel, or I'll say Robert. Okay. So if I press this, I'll get one row, right? And if I put explain plan, now what is the explain plan for this? I do a single amp operation. Now first we do a single amp retrieval step from steady dev student by way of primary index ttdev.students.name is equal to Robert with no residual condition into spool 1 amp, right? So if you see the difference between these two explain plans, here we are doing all amp operation with all row scan, and when you use the primary index in the where clause, we are using a single amp retrieval with a where primary index. Clear? So that is the importance of primary index and how the parsing engine will behave with respect to the primary index. So any questions on this?
Raj, how did you do the explain by pressing on which
F6.
which one?
F6. F6.
Okay.
This is the button I pressed it.
Okay.
Or if you want to write in the query also, you can do that. Explain and give you the query, and if you execute this, it will give you the same thing. Okay, either you have to do like this or F6. Okay.
Okay.
So it will give you the explain plan like how the data will be distributed based on the primary index. So you understand about primary index and the single amp operation, right? So any questions here? Akshay, clear? Biju?
No questions, Raj. Akshay here.
Okay. Biju?
Yeah, it's okay, Raj.
Now, so that is the primary index, right? So row distribution using the EPA. For example, if the number of keys are like this, and if you define primary index on the order number, so it will be unique, right? So all the data will be distributed evenly across all amps. For example, there are 4 amps in the system, and you have, for example, 9 or 8 keys. The data will be distributed evenly, almost 2 into each row, 1 extra row into any of the other amp. So the row distribution here will be similar and even when you're using the primary index. Okay. So whenever we choose a primary index in a column, and the data will be distributed based on the column in a evenly distributed fashion. All the distribution will be happening equally to the corresponding amps in Teradata. And whenever using non-unique primary index, okay, there are two types, unique and non-unique primary index, right? So unique will be like you know to obey single amp operation, and non-unique is also a single amp operation, but here what happens is whenever you choose a non-unique means what? Basically, uh, the index is not unique number. For example, order number here, right? This will not be a suitable candidate for non-unique primary index because this is value which is unique, right? And here customer number is actually a suitable candidate for non-unique primary index because customer number is repeating multiple times here like 2, 3, 1, right? So this can be a suitable candidate for non-unique primary index. But what happens with non-unique primary index? The data will not be distributed evenly, and for example here all 2's into one row, all 1 into 1 amp, and all 3 into 1 amp. So there might be some amps left, unfilled or unattended. So that what happens is the data distribution will be not even, and there will be like a skewness. Skewness is nothing but whenever amp is not being used properly, it will lead to a skewness factor. Skewness is also an important concept in Teradata. So on the performance point of view, whenever you see the data is not distributed accordingly or with respect to your primary index columns, your AMS will be skewed. Skewed in the sense it will not be properly utilized. So that's why we don't go for non-unique primary index. Depends on the requirement. And if the index is can handle duplicates, then we have to go for an UPA. Otherwise, UPA we have to define. And whenever you say uh, show select star from right, if I just show this query here, primary index by default it's a non-unique primary index, and unique primary index you have to mention unique while creating the table. That is what unique primary index. Now that's why you see the region. If I click from select star from students, you can see duplicate values also on the primary index because Joel is repeated twice here, right, in the name field. So this is a non-unique primary index, but it is still a single amp operation. But there will be like chance of getting the amp skewed in that. Clear? This is what non-unique in a primary index. Okay, and let's go to the secondary index. This is after your primary index distribution. We'll talk about secondary index now. Secondary index is also useful in terms of improve the performance of the query. Only thing is it will be like additional overhead to maintain in the tables because secondary indexes uh, you know can be created and dropped dynamically, unlike primary index, because primary index cannot be dropped. Once it is created, we cannot drop the primary index, whereas secondary index can be modified after the creation. Okay, so secondary index we can have 1 to 0 to 32 secondary indexes on a table. That is the maximum limit to have the secondary index, and secondary index will be like more than 1 amp operation. So I will show you the data distribution how it will happen. For example, if you take unique secondary index, right? So here the query is nothing but select star from customer, where customer is equal to 56. First of all, it will check in the customer table with the unique secondary value 56. So here there will be like two tables. One is subtable and another one is base table. Subtable will actually store the data with the corresponding secondary index value and the row hash value. For example, if you see here, this is the hash value that we get by using the hashing algorithm, right? So the first thing is it will just go for the hashing algorithm, and table ID is 100, row hash is 602, secondary index value is 56. Based on this row hash value 602, it will go for the subtable and check for the 602 row hash value and the corresponding secondary index. Okay, this is the row ID. Will you get the row ID for the corresponding value? and then we will check in the base table. Base table with the corresponding row hash value, that is 778, 7. This is what your row ID. Based on the row hash value, it will go to the main table, I mean the base table, to get the corresponding record. For example, here 56 is nothing but Smith and the phone number. This is the record that we are actually checking for, because it's a unique secondary index. There will be only one row with unique value as 56. Okay. So in secondary indexes, the data will be distributed in the terms of 2 amps. It is not a single amp operation. So let me just show an example so that you'll understand better. So here, if I just show the table to you, definition, the primary index is on the name table, right? Name column, and index is nothing but secondary index. When you say index, it means secondary index. Until unless if you use your primary keyword, then only it will be primary index, otherwise it will be always secondary index. Now I have two indexes defined. One is non-unique secondary and this is unique secondary, because I use the unique keyword. Let's talk about unique secondary index subject to. So now what I will do is select star from students where where subject to equals to, let's say, 85, right? I'll put explain plan now. So in the explain plan, first we do a 2am retrieval step from the way of unique index td dev students dot subject to is equal to 85 with no residual conditions. Okay, it's a 2am retrieval. As we discussed, there will be 2 amps involved in secondary index, unique secondary index, because one is the base table and another one is the sub table. Okay, here this is the sub table where you will have the unique secondary index value. This is from the architecture point of view how the data will be distributed. Okay, don't confuse about this. This is just a representation like how the data will be stored based on the index definition. This is the second index, right? So based on the hash value, that based on the hashing algorithm. So hashing algorithm is nothing but a simple like select, for example, hash row of name from students. So it will be giving unique value for the corresponding column. That is what hash row. So hash value is nothing but it's like a Teradata architecture where we'll get a unique identifier for each column, right? So based on this hashing algorithm only, the data will be distributed. It internally within the architecture of Teradata. So we don't know how the data will be distributed or not. I mean on a hashing algorithm, but that is based on the architecture point of view, right? So we don't need to get into that detail because how the data will be stored and all, but you should know the importance of second index, how the data will be retrieved. That is what. So here now when I say select star from where subject is equal to 85, the unique second index will be like a 2 amp operation, right? As I told you, there will be like 2 amp, will be one is subtable and one is the base table. So first of all, it will get to identify the corresponding row ID based on the hash value, and then it will go to the corresponding base table to get the corresponding record. And non-unique secondary index. So non-unique secondary index is actually more than 2 amp, because if you see here the same query, if you say non-unique secondary index value is equal to Adams, Adams must be duplicate value. That's why it is non-unique, right? So whenever you say value is equal to Adams, it will check for the corresponding row hash value. That is 567 is the row hash. It will go to the subtable. So 567 row hash value I see in the two different amps because Adams is a duplicate value. Since it is a non-unique secondary index, there should be like more than one record, right? So that whenever you say Adams, it will go to the corresponding hash value with the records called Adams. So it will be multiple records. So the subtable will be like 2 amp operation, and the corresponding base table will be like again two more amp operation. So if I just show you the example here, first of all let me just show you the definition of the table here. So in this, index is nothing but unique secondary index, because I don't mention the unique keyword here, and primary is not there. That means secondary index and non-unique secondary index. So subject one is a non-unique secondary index. Subject one, if you see, there will be like duplicate values. 45 is repeated, and you know, let's say where subject one is equal to 45, right? Because this is a non-unique secondary index. If I do the explain plan, first of all I will execute the query. I got 4 rows because of the duplicate rows, right? So it's a non-unique secondary index. If I do the explain plan of this, so it is saying first we do a distinct to read on the row hash value. We do an all amp retrieval and by way of all row scan. So whenever you use non-unique secondary index, it will be like more than 2 amps. That is all amp operation. So it will not distribute the data evenly with a non-unique secondary index. So because of the duplicates and all, it may be like n number of tables, right? So the corresponding table you can search entire amp structure to get these corresponding values. Okay. So whenever you write a query, you have to make sure by running the explain plan and say that any challenges issues with your P parsing engine guidance. This is very important explain plan from an performance tuning point of view, because you'll be like more writing of your queries, right? So explain plan will give you like how much spool space approximately and how confident your query is and all. We'll be discussing about those low confidence, high confidence and all in the coming classes, but so this is the high level on the primary index and the secondary index distribution of the data. Okay, any questions?
Secondary index that slide you had shown that 3 values, right? But can you tell me one more time what are the second and first? First is the table ID.
So yeah, this is the subtable ID where your row hash value will be given based on the hashing algorithm. For example, name is equal to Adams, right? The row hash value is 567, let's say. So for the corresponding value, it will go to the subtable first. Subtable is nothing but non-unique second index subtable. So I see Adams in 2 different names because it's a duplicate value. There will be like more than 1 row, right? So the corresponding hash value will be like 2 values, 567 and 567. And the row numbers is 638 and 471 717. There are 3 row IDs, right? So the corresponding row ID will be in the main table. So 638 comma 1 here, that is there, and 471 comma 1, that is here, 717 comma 2, that is here. So the corresponding records will be in the base table. Based on the row hash value, we'll get the row ID. Based on the row ID, we'll get the data from the main table, the base table.
Okay.
So that's why it is called a overhead, because secondary index will be again stored in a different tables, all the secondary index columns and all. That's why it is like a overhead to maintain in the DB. So normally we don't use secondary index very often in the real-time environment. We use primary index most of the times.
But I'm sorry, but for any database, there will be for any data if you take, there will be a need to have secondary index, right?
Yes, that's what I'm saying. It's not I mean compulsory, but we can have it. I mean, it's not like that we shouldn't use and all. We use it. Depends on the table structure and how important that we need to use as part of your query performance. Right?
Okay.
Because your primary index is itself is taking care of all your data distribution, then why we have to go for secondary index? It's no use, right? So based on the primary index columns, like primary index is not only one column, we can have up to 16th column we can add. So primary index can be distributed. For example, three column combination we can create a primary index. So that all three column combination must be unique. That is what a primary index, right? So we can create like composite primary index. Composite is nothing but adding multiple columns into a single primary index.
Okay.
So this is secondary index, right? So
Okay.
non-unique will be like multiple AMP operation. So we don't. I mean, it depends. Like we can, sometimes we have to go for non-unique as well, but mostly we'll go for primary index, non-unique primary index, because sometimes primary index can be multiple. Customer IDs can be into the same table, right? So we shouldn't use unique primary index there. We have to use non-unique primary index only, NUPI.
Okay.
And the difference between the primary and secondary index is nothing but, so index is required primary, yes, secondary no. Number per table, only one primary index we can create on a table. Secondary is up to 32. Number of columns is 16 for both of them. Unique or non-unique will have both the features. And row distribution affected by the primary, yes, but secondary, yes. Secondary, no. So that is a point here, because secondary index is just for the sake of having to filter the data further, but it will not affect the row distribution. Okay, the row distribution in the AMPs is only done by your primary index, and we cannot drop or create dynamically the primary index, whereas secondary index we can do that. And improve access, yes, and yes for both of them. Multiple data types, yes. Separate physical structure, for primary we don't have separate physical structure, but we have secondary, right, subtable structure. I just showing you two tables, but primary we don't have a separate structure. Okay, so we just thought like subtable and all, right. This is the separate structure for secondary index, but primary index we don't have it. And extra processing overhead, primary index no, secondary index yes, because we have to maintain this whenever we want to create and all. We have to maintain the secondary indexes separately. So primary index by default, right, we don't need to maintain it separately, whereas secondary index needs to be taken care of, right? So
Right.
this is the difference between primary and secondary indexes. So any questions on this so far?
Can we create the secondary index after the fact, after the table has been loaded?
Yes, that is what, right? Dynamically we can create. Yes,
So we can create as many as number of secondary index after the loading has been done.
up to 32.
Okay. Okay.
Okay. So, and here it's the difference between primary key and primary index, because primary key is actually a logical concept of data modeling in Teradata, whereas primary index is a physical mechanism for accessing and all. So primary key will be used as a relational modeling convention to identify the key, right? In PA is a Teradata convention which determines how the row acts are stored and accessed. Because in Teradata we don't have that concept is primary key. Okay, we are using primary index here. In Oracle and all, you might see primary key will have the key role, right? But here it's primary index. So in the logical model, like in the data entity diagrams and all, we'll be maintaining representing as a primary key only in the structure of the table. But ideally, in the Teradata environment, we use as a primary index. And Teradata doesn't need to recognize, each table must have only one. So we don't need to have a primary key. We can, primary index must be there. No limit on the column numbers, only 16 column limits for primary index. Documented in data model and defined in create table statement. So this is optional in the create table statement. Data model, you know, right? What is a data model? Data model is nothing but which will show you the relationship between different tables. There we meant represent as a primary key, but whereas while creating the tables, we have to use in the create table statement as a primary index. And primary key cannot be non-unique. Okay, it must be unique. But primary index can be unique or non-unique. And uniquely identified each row. Here, used and placed to locate each row on an AMP. So primary key is nothing but whenever you use a primary key, we cannot do insert duplicate, right? In any other database. But primary index is basically for the data distribution for the AMPs in Teradata. And values should not change. Values may be changed because the delete and inserts. Primary index is like non-unique, right? As well, right? So we can delete the values and create it again. May not be null, and here primary index can be null. That is the advantage in Teradata. We can still have the null value in the primary index. Does not imply an access path. It define most efficient access path. So primary key actually it will not say any access path for a row in a table. But whereas in index is typically defined for the access processing path only. Like based on the primary index, parsing engine will guide that okay, this is the primary index already on this column. Please go in this path to get the corresponding row hash value. Something like that. That is called accessing known access paths, right? And choose it for logical correctness and choose for physical performance. And this is in the data model that we choose for logical correctness, like while representing the columns and all. But this is for actual improving the performance in Teradata. So clear? So this is about the architecture point of view. So whatever we discussed is completely from the most deviate part of style because the distribution of the data, the row hash values mechanism in real time as a Teradata developer we don't go in such detail, but we should know the concept behind it because we'll be directly working on the SQLs and the joins in the queries, right? So if you understand these concepts while writing the queries, you might understand where to use primary index and secondary index, right? So that is a better approach while designing. But normally, as a Teradata developer, you don't get a chance to define a primary index on the main tables. Main tables, as I said, is like a fact table, the final target table where your data modeler will define the structure already and what should be the primary index on the column and all. So while doing the data model itself, they'll give you the tables with all the columns as the primary index and all. Ideally, we won't create any major tables. We'll create our work tables or temp tables in between, right? There we define the primary index for our convenience. But most of the dimensions and fact tables in real time, we don't define the primary index and secondary index on that because it will be taken care by your data modeler. But until unless if you go in that way, I mean you don't have an opportunity to create those table structures and all. Okay. For example, if you take healthcare domain, you define claims table. That is a very key table in healthcare. Like claims table, there will be like claim different tables will be there, right? Claim and claim line detail and medical claims, pharmacy claims. Different tables will be there. So claim will be defined with some unique primary index and some values in that. That will be defined by your data model. What type of column we should have and what is the best candidate for primary index, because they have to keep in mind all the factors of your data distribution, how different from other tables, because it can be joined with other tables as well, right? But they should have relationship between each table, climb and climb line. The hierarchy should be followed, right? So something like that. But I mean, as initial stages like a developer in the senior developer range, we'll be focusing on mainly performance of the queries and you know using Teradata scripts and how to perform the queries, tune the queries. That is what we need to know. So any questions?
Yeah, what is a Teradata developer do? Like, Um, I know the other ETL tools are used to load it, and the reporting like Cognos will take it and report it. And so, what is this Teradata SQL?
Data only. I mean, if you're working on Teradata database, all your SQLs will be in form of Teradata, where we pull the query from Informatica and loading into the target table, right? So your SQL will plays a major role here. That means in the transformation or BTEC script, doesn't matter. At the end of the day, we use this Teradata SQL. The SQL will be compliant of all the joins and your queries. Okay, let's say joins or queries on the tables to get the corresponding data, business required data, right? So this will
Okay,
be loaded into the target table. So this target table loading is still again with the Teradata utilities only, like fast load or F load, you can say M load, and then TPT, fast export. There will be different mechanisms in Teradata, along with the ETL tools like Informatica have this provision to have all these utilities with Teradata. So from the once we pull the data from the source, we load the data by using these connections from Informatica to the Teradata target database. Your database is again a Teradata database, let's say. So as a developer, you should know how to write your queries to pull the data, and while loading the data, what are the connections that we use, float, mload, tpt, and you might write some btech scripts. Btech is nothing but batch Teradata query. So we can call as btech.sh from Informatica. Otherwise, you can write a btech directly in a Linux command prompt. Okay. So in btech, what happens is we will call multiple SQL statement in a sequential order. That's it. So if you wanted to do some, first of all, create table statement. Let's say create a table, creating the table and inserting the table with some data and updating the data, and we do some manipulations and all, right? So everything can be done in a single SQL, that is called btech. So we'll be putting all these comments into a single thing, and we call these btech scripts from the Informatica either, or otherwise directly Unix also we can call in the form of LST files. So the btech can be used by the Teradata, which will be saying the doing the same operation, like getting the data from the tables, loading from the tables. So as a Teradata developer, you completely work on SQL. If you use TPT, mload, float, fast export, and btech, these are the utilities in Teradata which will be helpful to load different type of data into the tables or pulling the data from the tables. So as a developer, you'll be working on all these utilities on the sequence and query tuning the queries, because most of the times when you use Teradata, what happens in Informatica combination, let's say any ETL tool, you write a SQL in the transformations, you have to tune this SQL because there will be like hell lot of tables and with different type of joins, right? So we need to know what are the joins that we are using and the tables. And as a developer, Teradata developer, we should know how to use those tables in an appropriate manner, right?
okay,
Tuning the queries, basically as a developer, these are the activities. Tuning the queries, automate the tasks using bash scripts, btex, just avoid manual intervention, and then performance improvement. That is nothing but tuning, right? Performance improvement, unloading the target, and you can provide business queries as well. And analysis, most important is analysis, because whenever business says I'm not able to see the data for the corresponding claim or member, so based on the key value they'll provide member. Let's say they give you some member ID and they'll say that I'm not able to see any data in my target. So you, how you do analysis, based on the given information, you get into the tables with the member ID where member table, join with other tables to get the data and do the analysis and provide the results, right? These are the regular activities on a day-to-day basis as a Teradata developer. Clear?
yes. So the SQL developer, this portion of the Teradata tool is used only to verify, and the SQL after the
Yes.
verification we use
This
the
is
same
only
SQL.
for the queries and the basic things. The normal actual things will be done at a server level, but we don't have access to the server directly. But in the real-time environment, we have the Linux environment where you can actually your ETL and Teradata install on the same server, right? So this Unix server basically we can call the BTEX scripts and mload scripts, and I will tell you in the scripts coming into the next classes how to run a script from command prompt and how to execute the queries. So this SQL assistant is only writing for SQL queries and understanding the joins and all, right. But actually the processing can happen from the server side directly. The BTEX scripts and all we cannot call BTEX from SQL assistant. Okay.
Okay.
This is only for SQL. The name saying
Okay.
SQL assistant, and the remaining things can be invoked from the command prompt from the server. This is the server, Teradata server, right?
Okay.
Okay.